So I'm going to prove that these two triangles are congruent, and I need to know three things, unless for the HL, unless it is a right triangle. So in this case, I'm already told a side, an angle, and a side. So you want to follow that in order. Side, angle, side. If that angle is in between those two sides, if it's tucked in between those two sides, then it is side, angle, side. That proves they're both congruent. Let's look at this one. Here we're just told two things. We're told this angle is congruent to this angle, this side is congruent to this side, nothing else. In this case, you always want to look to see if, first off, if they are sharing a side, if they're smushed together, or if there's any vertical angles that are congruent. So remember, when two lines cross each other, they make a set of vertical angles. So this angle here is congruent to this angle here, because these two lines cross each other to make these vertical angles, and then also these two over here. So now we know three things. You really just need to zero in on one of those triangles at this point. So if we look at this triangle, we see that there is an angle, and a side. Angle, angle, side. So let's look at this one. Again, we're just told two things. We're told these two sides are congruent and these two sides are congruent. You want to look for any vertical angles from intersecting lines. I don't see that, but I do see that both of these triangles share a side right here. This YQ line is the same length for this triangle here and the same length for this triangle here. It is congruent in both of these triangles. So this is our third side, the third thing we know. So if we now zero in on one of those triangles, we can see we have side, side, side. Three sides are congruent. So since three corresponding sides are congruent, we know that those two triangles are congruent. How about this one? Here we're given three things. We're giving an angle, side, angle, or side, angle, side, side. Or you could say side, side, angle. So if we look, it's not one of the options. And so you can kind of remember this word is like a bad word. These don't exist. So if this is the case, you know that there is not enough information. And even though we do have two sides and an angle, it's important to note that the two sides and the angle, this B, only works if that angle is in between those two sides. So it would have to be this angle here instead. That's in between those two sides. So this one is not enough information. Now if we look at this one, we're told a couple of things. We're told that this is a right angle, so this one must be a right angle too. These sides are congruent. Remember, when triangles are smushed up against each other, they're sharing the same side. This blue line here, RV, is the same length for this triangle as it is for this triangle. So this is our other congruent side. So let's look and see what we know. We have side, side, angle. Or you can think of it as angle, side, side. Remember, we just talked about that. That one doesn't work. But there's one case that it does work, and that is if it is a right angle. If that angle is a right angle, you can use it, because if it's a right angle, this is the hypotenuse here across from that right angle, and this is one of the legs. These two are legs. So if the hypotenuse is congruent in both triangles and one of the legs, the hypotenuse leg theorem tells us those two triangles are congruent. And lastly, let's look at this one. We're told these angles are congruent. They're both 90 degrees. They're congruent. And we're told that the length of this side is 5 and this is 5. So what else do we know? Since these are two intersecting lines, we know that this angle and this angle are also congruent because of they're both vertical angles. So now that we know 3 things, let's just zero in on one of those triangles. Remember that if we have a right angle, maybe it's that hypotenuse leg one. But the hypotenuse, we don't know anything about the hypotenuse. So it's not E. Let's look. Angle, side, angle. The side is tucked in between the two angles. Angle, side, angle. So the angle, side, angle theorem proves that these two triangles are congruent.